Hello children, welcome to a new episode for the blast from the past, the JEE advanced previous year question discussion. And today we have another question from chemistry. Year is 2022 exam paper question, right? Go through. 2 mole mercury gas, 2 mole Hg gas combusted in a fixed volume bomb calorimeter. Bomb calorimeter means constant volume experiment with excess of oxygen at 298 Kelvin 1 atm into HGO solid. During the reaction, temperature increases from 298 to 312 Kelvin. Heat capacity of bomb calorimeter. Heat capacity of bomb calorimeter 20 kilojoule per Kelvin. And enthalpy of formation of Hg gas. Enthalpy of formation of Hg gas means Hg liquid converted to Hg gas. It is given 61.32. 61.32 kilojoule per mole. We want to calculate standard molar enthalpy of formation of HGO solid. We want to calculate X mod X is. So we want to find out standard molar enthalpy of formation of HGO solid. So what is the equation for finding molar enthalpy of formation of HGO solid? It will be Hg in the liquid state plus half O2 gas giving HGO solid. We want to calculate this. But that cannot be straightly calculated as the experiment is conducted in bomb calorimeter. You are able to find out delta U. So from delta U, you can find out delta H, isn't it? So what is the formula? Delta H equal to delta U plus delta nRT, isn't it? Delta H equal to delta U plus delta nRT. So let us go for delta N. Delta N for the process Hg gas. Delta N for the process Hg gas. Hg gas plus half O2 gas giving HGO solid. For this you can find out delta U. How to find out delta U? Heat capacity is given 20 and temperature is given. So C delta T will be 20 into, what is delta T? 312, 298. So it is 298, 308, 312, 14.8, isn't it? So it is 14.8. This much kilojoule for 2 mole mercury. For 2 mole mercury. So what about 1 mole mercury? It will be divided by 2. So it's 148, isn't it? 148 kilojoule. Since it is a combustion process, it is minus. So delta U, you have been able to get minus 148 kilojoule per mole. Hope it is clear. Fine. Now delta nRT. Delta nRT. Delta N for the process. Delta N for the process, it will be product side solid 0 minus reactant side 1.5. So it is 3 by 2, isn't it? 1.5, 3 by 2. So it will be, the calculation will be minus 148 minus 3 by 2 into R value given 8.3. 8.3 into 10 power, it is in joules. 10 power minus 3 kilojoules. 10 power minus 3. Temperature 298 Kelvin. 298. How much you are going to get? So this 298 I am taking as 300 with the 10 power minus 3 will turn 0.3. 0.3 with 8.3. 339. 2.49, isn't it? 2.49 versus 2. It is 1.24 something, isn't it? 1.24 something. 1.24 something into 3. It is 2, 12, 7, 3. So it is 3.72 minus 3.72. Minus 3.72 with this. It will be minus 151.72. That is delta H. That is delta H for this reaction. That will be delta H for this reaction, isn't it? How do we find out? Delta H is equal to delta U plus delta nRT. So calculating that, we get delta H. Delta H for this process. We want delta H for this process, and you see the difference. It is Hg liquid. It is Hg liquid, and it should be converted to Hg gas. It is to be converted to Hg gas and then proceeding the reaction. This one we have the value minus 151.72, while this value given plus 61.32. I don't have to tell you, enthalpy of vaporization, endothermic process, it will be plus. So what is the net figure? Net figure will be minus 151.72 and plus 61.32. What is the answer? 0409. So it is minus 90.4. Minus 90.4, and we want the modulus. It is 90.4. That is the final answer. That is the final answer. I hope it is clear. I'll repeat. We want to find enthalpy formation of HGO solid. Enthalpy formation of HGO solid will be Hg liquid in the standard state plus half O2 gas giving HGO solid. While the reaction given in the bomb calorimeter, it is Hg gas. So this is the reaction available in the bomb calorimeter. And in the bomb calorimeter, it is constant volume process. We are getting internal energy. So by internal energy, you can get enthalpy. And that enthalpy is in the form of Hg gas. We want to get it for the Hg liquid, right? Now, how do you get enthalpy from there? Delta H is equal to delta U plus delta nRT. And how to get delta U? Delta U can be obtained by taking the heat capacity of the calorimeter and change in temperature. C delta T will give you delta U. How? 20 given in the question, and temperature difference 14.8, and that is for 2 mole mercury. For 1 mole mercury, it is by 2. You get minus 148. My plus delta nRT. For this equation, delta n is 0 minus 1.5. So it is minus 3 by 2. So minus 148 minus 3 by 2 RT will give you minus 151.72. That is delta H for this process. We want delta H for this process. So delta Hg liquid converted to Hg gas. There is the value given in the question, 61.32. That will be subtracted from minus 151.72. You get the answer minus 90.4. That is the value. We want to report in terms of only modulus. So the final answer will be 90.4. Right? That's all. A question, beautiful question from thermodynamics. And we will meet with another question in another class. Till then, bye. See you.